Welcome to the tutorial on review of ODEs. In this particular tutorial or tutorial review, I would like to illustrate how to visualize the linearity of ordinary differential equation. So that's the objective, how to is to visualize geometrically what is the geometrical meaning or interpretation of linearity of ODE, or why do we say ODE is linear? Where is the line in the linear ODE? I mean, because you may wonder, like when we solve the ODEs, even if the ODEs are linear, the solution are not linear. So what is the linearity? What is that all about? How to visualize it? How do we see that and verify by seeing and plotting that it is linear? Let's explore this avenue, which otherwise is relegated to a definition in textbooks that if the ODE is of this type, you say it's linear. If it's defined to be in this particular way, it's linear. Otherwise, it's non-linear. And then there are some characteristics like, well, if it's if it obeys or respects superposition and things like those, and there's that idea of linearity as well. But pure and simple geometric visualization is what we are after. And most likely, this will not be something that you will find in textbooks out there. Yet, it is it is a verification by way of plotting and visualization the definitions that are shown to be used for determining linearity of ODE in math and calculus textbooks. So let's get started. So I'm going to open my, let's see. So here's the script that I've written for visualizing the linearity. So how do we approach this? So I'm going to use five uh, demonstrations or five plots to show for each one that the ODE is linear. ODE hereafter is ordinary differential equation. So first equation that I'm going to use is y prime. And when I say y prime, I'm writing prime because in MATLAB comments, I cannot write over dot, at least like I'm not that far advanced to write in latex in script. I haven't seen anybody do that, but feel free to let me know in comments if it can be done that in script I can write over dot in a simple script, not a live script. Okay, so y prime of t plus, so this is dy dt plus y of t equals cosine of t. Let's say that's the first order differential equation. For those of us who know it's linear, I'm not going to explain why it's linear. As I said, the purpose of this video is to show by verification, by plotting, that it is linear. So what I'm going to say here is, here's the line, or here's the reasoning that I'm going to employ. The reasoning is, think of this as one variable. Dy dt is one variable, y of t is another variable. So if I were to plot y of t versus y prime of t after solving this ODE, whatever that comes out as nonlinear expression, but if I keep that entire function on the horizontal axis, so y of t on the horizontal axis, y prime of t on vertical axis, then if this ODE is linear, it should represent, or it should come up like a line. So if I plot y of t versus y prime of t, I should get a line, equation of a line. And because this is like x plus y equals something, or 5y, or I should say y plus 5x equals something, it should be a line with a negative slope. So not only it should be a line, it should be a line of a negative slope. So we're going to verify that as well. So with that said, uh, let me also point out that for those of you who want to verify this, this is the solution. And I'm going to pause for a few seconds. So if you want to pause this video and take a note of the solution and then verify it yourself. When I say verify it, back substitute in the ODE, do the algebra, verify that right hand side is left hand side, or left hand side equals right hand side. But I cannot plot with the constant in here, so I'm going to use the initial condition that at time t equals 0, y equals 0. So then the solution will be this. So solution to the initial value problem, if you will, meaning the ODE combined with the initial condition, will be this. Again, please feel free to verify by paper pencil or plotting it in, or substituting it using symbolic algebra, and let the software do the math like Mathematica, symbolic toolbox in MATLAB, and so forth. Because my focus is on the plotting, I'm not showing all those things of how to use Mathematica or MATLAB or Maple. Okay. Having said that, I'm going to now define a function handle corresponding to the solution y, and then similar function handle for dy dt. So dy dt is differentiation of y with respect to time. So dy dt is supposed to be dy over dt, but again, if I write slash dt, MATLAB will not like it. So that's why it's written like this. So figure 1 is what is going to be generated if I were to plot y on the y-axis, sorry, x-axis, horizontal axis, and divide dt on vertical axis. So what I was saying is I should get a line. It should be line of a negative slope. And then there are like these fine details about how to write over dots in MATLAB and y dot and things like those. So for now, what I'm going to do is I'm just going to comment out everything so that I can show you one thing at a time, and then comment out. So we are only going to run the first section, and I will put this script for the whole world to see and use, so that everybody is standing to benefit not only by watching this video but also getting a code that they can use in their classes for the self-study, whatever. All right, at this juncture, let's run the code. So click run. Voila, I get line with a negative slope, just as predicted. Furthermore, take note of the slope of the line. The slope of this line should be -5, and that is what you are going to also observe here. All right. Once I give you the code, you can play with this and verify that the slope is like that. Okay. So this is the first proof that this is a linear ODE. When you plot y versus y prime. So here I have shown as y over dot. So in plot, I can write over dots and things, but in common script, I could not. So having shown this verification that is a linear, because this is equation of line, meaning this is a line that we see as a plot when plotting y versus y prime. I'm going to close this, and then I'm going to uh, comment this out and just plot the second one. So you can see one thing at a time instead of getting burdened with 5 plots concurrently. And then you may feel like, oh my God, this is way too much uh, to handle in terms of work. So let's uncomment, oops, undo. So now let's uncomment the second section. So second demo is what I'm going to uncomment and run. So now second ODE is a simple, very simple linear homogeneous ODE, y double prime of t plus 25, y of t is 0. We know that the solution is going to be, if it was general solution, as in the homogeneous solution, but without initial values applied, it would be cosine of 5t plus, meaning constant times cosine of 5t plus some other constant times sine of 5t. But when I use the initial condition, y of 0 equals 1, y prime of 0 is 0, I get just cosine of 5t. And you can verify, if I put t equals 0, I get cosine of 0, which is 1. Y prime would be 5 times, or -5 times sine of 5t. And then if I plug in 0, I get y prime of 0 is 0. So I know that this is the right solution. Again, I have defined function handle for cosine of 5t. And now I want to plot, if it's linear, I should be able to show that this is a variable like y, this is a variable like x, and the slope of this line will be 25, -25 to be more accurate. So if I were to plot y of t versus y double prime of t. So y of t on the horizontal axis, y double prime of t on vertical axis, meaning second derivative of y on vertical axis, I should get a line, and I should get line of negative slope of 25. And now we are going to run this script again, but again only on this section. So we should see that if my claim of it being linear is correct, I should see a line. So run, voila, we see a line. Horizontal axis is y sub 1. I call it y sub 1 because I didn't want to use the same y for everything. So y sub 1 d square y1 over dt square is the y double prime there. And you can see line of a negative slope, and it's 25. I let you verify it's 25 because I'm going to give you the script once I'm done illustrating this. So with that said, close this guy, comment this out, and then go to next section. So I'm just using all linear ODEs. And if this ODE was if you take any non-linear ODE like this, you will be able to see it's not a line. Okay, so that goes without saying. And that is left as exercise or homework, if you will, for the audience. Please know that I'm not your instructor formally. I mean, unless of course you're taking course with me, you're not my student, then I don't have obligation to uh, answer, basically provide solutions to your request. All I will give you is clues in that case. But if you are my student in the class, by all means, you can always email me and seek my help. As I was saying, I was going for third demo. There are 5 of them. I'm scrolling to see where the third demo went away. Okay, here. So now the third demo. Okay, so now the equation that I am using is similar one as previous, but with a negative sign. So if it's a negative sign, the nature of the solution changes. Now I'll get cosh and sinh, meaning hyperbolic cosine, hyperbolic sine, or e to the minus 5 to 5t and e to the 5t, that kind of combination. But instead of writing c1 times e to the negative 5t and plus c2 times e to the 5t, e as an exponential of 5t, I'm writing just hyperbolic cosine. And hyperbolic cosine being a solution to this with this initial condition, just like before, if I were to plot y of t on the horizontal axis, y double prime of t on vertical axis, I should get equation of line. And because there's a negative 25 here, it means I'll get line of positive 25 units as slope. Because think of this as y minus 25x equals 0. What would happen when you plot y minus 25 equals x equals 0? You get line passing through origin with slope of 25. So similarly here, you will get a line passing through origin when I plot y of t versus y double prime of t. So run and voila. Line passing through origin, positive slope of 25. So we have verified that this is a linear ODE as well. Now you may wonder like, well, how come you're not plotting or showing illustration for inhomogeneous or non-homogeneous ODE here? Why are you only showing homogeneous ODEs? So now I'm going to plot inhomogeneous or non-homogeneous ODE of a simpler type where I've got y double prime of t minus 25y of t sine of t. So again, I'll say that although there is a forcing function of sine of t or inhomogeneous term of sine of t, and the solution changes, overall solution to the boundary value problem, if you will, or initial value problem, if you will, uh, changes, but the nature of the equation does not change. And what you will see here, you will also get the same kind of curve as before with slope of positive 25. Although there is sine of t here, it doesn't matter, and you will see why. Note that I'm using fplot command, which is plotting functions directly. So I'm having MATLAB do all the hard work for me, and I'm focusing on the end result here. So with that said, run it again. Once again, similar curve, d square y over dt square and versus y, positive slope of 25. Finally, we are going to make it more interesting. Now I'm going to use an inhomogeneous ODE where I've got y prime and y triple prime, sorry, y double prime. So in that case, what I would have is 3 variables. So if it's a 3 variables, it's a line in 3D. If it's a line in 3D, oops, I forgot this guy. If it's a line in 3D, I need to use fplot3 command to plot 3D. So then I should be able to show that if I have or if I got y prime and y double prime, I should be able to plot it on 3 axes. And then I should be able to show that when plotted on 3 axes, I should get a line in 3 dimensions. So uncommenting, oops, my bad. I had to uncomment it and I just ended up commenting it once more. So we are going to have to do it twice now. Okay. So now here's my ODE, y double prime of t plus 3 times y prime of t plus 2 times y of t equals sine of t. So y double prime is d square y over dt square, y prime is dy dt. So here's a inhomogeneous or non-homogeneous ODE because of the non-homogeneous term sine of t. But this is still linear because this is a linear combination. Think of this y double prime as z, y prime is like y, and y is x. So it's like x, y, z. So it's almost like saying z plus 3y plus 2x equals some number. then that's the equation of a line in 3 dimensions. And thus this ODE would be linear if I can show that, if that can be verified. So we are going to solve this problem using initial conditions. Y of 0 is 1, y prime of 0 is 0. So for that initial condition set, the initial value problem solution is this 1 over 10 exponential of minus 2t. And again, it's right here. Pause the video and take note of it if you wish to verify. And now I'm going to run this again. I'm going to now this time around I have to have 3 functions: y, y prime, y double prime. So I'm using y sub 4 instead of y. So y sub 4 dy 4 dt is first derivative of y. D square d2 y4 dt2 is second derivative of y, or y sub 4 here. And then I'm using fplot3 command to plot 3-dimensional line. So having this y4 on x-axis, this on y-axis, this on z-axis. And you can see that I'm using xlabel, ylabel, zlabel for that purpose. And now if my assessment of this is correct, that this is a linear ODE, then I should be able to show that when I plot those 3, I get equation of line, regardless of how complicated non-linear expressions these are. So click run, and voila. And I'm going to rotate it for you. You can see this is a line. So thus we have verified that this is equation of line, and this is how you can geometrically visualize what it means when we say a linear ODE. And with that said, I'm going to stop here, but I also would like to add a remark that I've chosen ODE with constant coefficients. So these coefficients are constant, like for example, 3 and 2. Now somebody may ask like, well, if you had t here, for example, if I were to write 3 times t, it would be still a linear ODE. That's correct. It will be linear ODE. Then what would you do? Well, then you have to choose a particular value of t for that purpose to be able to plot it, because then things would work out properly. Otherwise, it would not. So for an a particular value of t, the combinations will correspond to equation of line, and it will be still linear. But instead of t, if I were to put y here, now it becomes non-linear. So it would be like writing z plus 3xy plus 2x equals 0 or something. So now it's a non-linear equation. So geometrically speaking, it would be not a line in 3D. It would be some curve in 3D, or depending on how you view it, it could be a surface. So with that said, I'm going to stop here. Thank you for your time and interest, and see you later. Bye now.